last presentation of this panel, which will be presented by Chris Atherton. Chris is a Senior Research Engagement Officer at Géant, an infrastructure organizing, providing cutting-edge pan-European networking and trust and identity services exclusively for the research and education community. Chris, please take the floor.
Thanks very much, Jose. Are you able to hear me okay?
Yes.
Yeah, perfect. Distinguished guests, ladies and gentlemen, good afternoon. I'm here to talk to you about international connectivity for research and education. But first, I think it's probably worth going into a little bit of detail about just who Géant is. Géant is an association, a collaboration of European national research and education networks, or NRENs. We support the advancement of research, education, and innovation on a global scale. Our membership is made up of over 40 national research and education networks spread across Europe. And together we support about 10,000 institutions and around 50 million academic users. But the origins of Géant go back to the early days of the internet. In the late 80s and early 90s, there was a need to move research data from CERN and other big research infrastructures to academic users around Europe and the US, Russia, and India. The commercial providers that were capable of doing this weren't able to serve the academic users in the way that they needed. And so the European Academic Research Network, or EARN, was first set up in the early 90s in collaboration with a few national research and education networks in Europe at the time, including in Portugal. From those early days, Géant, or EARN, has now evolved into Géant and has expanded to become a not-for-profit membership organization representing, as I said, over 40 different national research and education networks across the continent of Europe, including FCCN. This network spans from Iceland all the way over to Azerbaijan. Géant not only connects each of those 40 networks together, or the 40-odd countries together, but it also connects Europe to the rest of the world at multiple 100 gig connections. So far, we connect to over 140 different countries globally. We pass around a terabyte of data a second on the network. We connect those big research organizations that span multiple countries, like CERN, the European Space Agency programs, EUMETSAT, and SKA, as was mentioned before. We work with partners in other world regions to help create the global research and education networking community, like in Latin America with our partners Red Clara, or in Africa, Ubuntu Alliance, BACREN and ASREN, and others in Asia and in North America as well. This is so that we collectively, as a global research and education community, can pass data freely amongst one another to benefit the advancement of science globally and to help researchers do the work that they need to do. But Géant is not just a network, nor is it just a membership association. It's also a project, strangely enough, called Géant. And it's made up of staff from the European NRENs, from the Géant organization itself. And we work together to develop services that researchers need to use in order to perform the work that they do. I'll give you a few examples of some of the things that we've done within the project. I think that other than the network, this service, Eduroam, is probably our most famous that we've developed within the project. It's a free Wi-Fi roaming service so that academics from all participating institutions can gain access to the internet seamlessly so that they can get on and collaborate. If you imagine a researcher from Lisbon University going to Milan Bicocca University, they can just open their laptop up and start working straight away with their colleagues and peers. There's no need to search for a username and password or ask the IT administrators what they need in order to gain access to the network. This is a global, worldwide success story. We're really proud of this, and from its early beginnings with just a few European universities, it spans, as I say, across the world. Building on top of Eduroam, we as a community also developed a service called Edugame. This is a federated single sign-on service. This is a way for you to use your institution username and password, the same that you'll use to log into your email address, for example, so that you can use that username and password to access web portals or compute facilities or anything that you need. You just have one username and password to gain access to everything. And the advantage of that is you don't have to waste time searching for your password. It's more secure because you actually log into your home institution rather than to the service providers themselves. And because of that, it's easy to keep a track of everything that's going on. These are just a few examples of the type of services that we create to help researchers. But who are those researchers that I'm talking about? What are they doing, and how is Géant helping with its involvement in international research and education networks? An example I've got for you is something that's close to my heart, which is the Copernicus project. As some of you may know, Copernicus is Europe's flagship Earth observation infrastructure project, our own infrastructure to collect Earth observation data for the benefit of governments of the member states, for civil society, for industry and academia. This program cost about 6.7 billion euros, and all of the data is made available free of charge. This data doesn't just come from the 9 satellites that are currently in orbit, but from in situ data points, so sensors on the Earth. Géant provides the underlying connectivity infrastructure to link the data sources to the academic users in Europe and to other selected partners around the world. On average, around 40 gigabit a second of Copernicus data travels across our network, and that's the equivalent of around 13 Mac OS updates a second. And if you can consider it takes about 3 hours to download a Mac OS update, it gives you an idea of the capacities that we're talking about. But why is this data needed, this amount of data? Really, as was mentioned in a few slides earlier or in a few presentations ago, it's to tackle 3 global challenges. They are disaster and emergency response, sustainable development, and also climate change, most crucially. And these are addressed by the Paris Climate Accord, the 17 UN Sustainable Development Goals, and the Sendai Framework. And you're probably wondering how that connects together. Well, a cable system like Bella will dramatically help to increase the ability of researchers in Latin America, for example, to perform the research that they do into climate change, into emergency response, and also into the Sustainable Development Goals. Right now, all that Copernicus data flows from Europe, from Greece, over to the United States of America and then down to Latin America before it's able to reach any of the researchers. With Bella, for example, it should take a download of a Copernicus file, which would normally take 15 minutes. It will reduce that download to just over 5 minutes. This data, as has been said, will be used for monitoring pollution, crop development, and many other things. And this is just an example of the work that we're doing to support global research and education through international connectivity and the network services that go on top of the underlying cable infrastructure. And other than working on the connectivity to support research, Géant's continuing to innovate ourselves with some of the latest technologies to support scientific advancement. Things like quantum communication or quantum key distribution, time and frequency distribution, and also smart cables, specifically for ocean and climate research. So one of the projects that I'm working on at the moment with my colleagues is a project called Geolab, and this is using a cable or a spare fiber that's now being made available due to the implementation of the Link cable between Portugal and Brazil. This has opened up an opportunity to integrate a scientific component into a commercial submarine cable system for the very first time. Sadly, it doesn't have the sensors that Bruce and Yasser were speaking about. Instead, it requires a land-based signal to be generated in order to turn the cable into a sensor. But Geolab's being created with a number of partners and involvement from some of them today. Elelink, for example, Emicon, FCCN, the JTF, and LEA, to try and work to get this infrastructure going for the benefit of the global scientific community. This laboratory will allow researchers from many different disciplines to bring their own equipment to the infrastructure to generate the research data that they need in order to do their work. Some of the areas of science that we're hoping that this kind of project will benefit are the likes of the seismological research, anthropogenic movements, volcanology, benthic investigations, but also space data validation, abiotic and biotic marine interactions, cytology, so the investigation of orcas, whales, and dolphins, and also technology validation, so that we can help try to prove some of the techniques and validate some of the new sensors that are potentially being developed to benefit everyone globally. This cable has already been installed as part of the Elelink implementation process, but the infrastructure is not actually set up fully yet. And at the moment, we're seeking interested research groups who may want to use the cable so we can build a case for developing this system. So, yeah, I'd just like to say, I hope that gives you an insight into some of the work that the Géant community is involved in at the moment. And I'd like to thank ANACOM and the Portuguese presidency for the opportunity to present. And I look forward to answering any questions that you may have. Thanks very much.
Thank you very much, Chris. Chris, other than research domain innovations that you mentioned, like quantum, time and frequency distribution, what other exciting things is the Géant community working on?
There's plenty at the moment that's going on. We're currently upgrading our backbone network to cope for exascale computing. So although I mentioned that we could cope with a terabit a second, we know that the likes of the work that's going on with the square kilometre array, we need to make sure that our network is able and capable of dealing with the flows of data that researchers not just want today, but in the future as well. There's also other things, say, for example, cloud services. We are part of a project, part of the European Open Science Cloud, that's called OCRA, the Open Cloud for Research Environments. This is a project for providing vouchers to researchers so that they can gain access to commercial cloud compute facilities. There's plenty of others, especially in the trust and identity field as well, like EduTeams, which is a authentication authorization infrastructure service. And this allows communities to be able to manage roles and memberships from edugame and from non-edugame members as well to access services. So yeah, there's plenty of interesting things going on that are quite exciting at the moment.
Okay, thank you so much.